All right. So to start, we're moving away from. So we're moving into actually solving quadratic equations. And as with everything we've learned how to solve, we always start off by looking at graphs. When we did systems, we did that. When we did inequalities, we always start with graphs because they're the visual one. They're the first method that we learn. So graphs and tables. Before we do that, we kind of need to address some vocabulary. So there's a lot of information here, and some of it is has a lot of big words. But what really matters is this part down here. This is the really, really important part. Remember how we have two words that mean x-intercept? We have x-intercept and 0. Remember that? We're going to add 2 more. So we need to make sure that we know what those words are. It is really important that we know what those words are. Okay? So we have roots or solutions of a quadratic equation, or the zeros or x-intercepts of a quadratic function. Okay? So those are new, some of those are new vocabulary words. And again, somebody in second period was like, why do we got to make everything so complicated? Why can't we just have one word? Okay, well here's the thing. Again, I said it before, I'll say it again. So a couple of years ago, maybe 5 years ago, I had a student in my class who was my friend's daughter. And she had called me Maggie her whole life. Do you think she was allowed to call me Maggie in here? No. When she was in this classroom, she called me Mrs. Deal. So when we were in class, she called me Mrs. Deal, but she called me Maggie all the rest of the time. Because I have different names in different situations. Molly calls me Mommy. You know, sometimes, well, David calls me Maggie. My mom calls me Sweetheart. You know, everybody else calls me Maggie. Strangers call me Margaret because they don't know my name. I don't go by Margaret, I go by Maggie. So I have all these different names. They apply to me in different situations. And it's the same thing here. One of the reasons they call it a root is because in order to find the solution to a quadratic or a cubic or something, I have to take a root to find it. Because it's squared, to undo squaring, I have to take a square root. If it's cubed, to undo it, I have to take the cube root. So we call them roots because that's where my roots are. That's where my square and cube roots are for that solution. They call them solutions because remember, when we solve an equation, the answer is called the solution. When two graphs cross, their answer, the point that they cross at, is their solution. Solution is where something is the answer to something. A 0 is because it is the answer, the x value, and y is 0, and the x-intercept is because that's where it crosses the graph. So they're all different, slightly different takes on the same thing. The door, please. And so, but what you need to know is they're going to start using all of these now. Okay? Solutions is a special one. They call it the solution, and actually I'll show you in a minute when I would say 9 times out of 10 for solution they mean the x-intercept. But there's one circumstance where they don't, and I'm going to show you that one today. Okay? But you have to start getting these words into your vocabulary. I'm not going to spend another 4 months getting you to understand that a 0 is an x-intercept because we don't have that much more time until STAR. We've got 2.5 months. Okay? So you got to get on this. You got to know that roots, solutions, zeros, x-intercepts, they all kind of mean x-intercept except in one certain circumstance. Okay? So you're going to put that in your notes later. Let's get out this new big yellow, what is this, orange book. And this is, we're going to take notes in this. So this is going to be our notes for this whole unit. The next 2 tests, these are going to be our notes. Okay? So we're going to go to the first tab, and we're going to start looking at that first method, which is graphing. And remember, we always start with graphing because, because it kind of makes sense. You want to look at it. You want to see what it looks like. All right, so on this page, what we're going to do is we're going to start by actually graphing these situations. Okay? All right. So what we're going to do is we're going to start off by graphing this. So I want you to put this equation in your calculator. Y'all don't work ahead. There's some mistakes on this thing. So I will model, oh wow, that got bright. I will model this first one with you, okay? But I want you to actually, so we're going to do the first one, and then I'm going to let y'all do the second one. All right? So the first one, we're going to put, see it says 0 equals x squared plus 4x minus 5. So we're going to put the x squared parts. We're going to do x squared plus 4x minus 5. Okay, NY1. And then we're going to look at the table. Now, remember, we don't always do this. So I don't want you to think that the vertex is always in the middle of the table. When we build our own table, though, we want the vertex in the middle of the table because that helps us understand and see the shape of the parabola when we graph it. Okay, so when we're making our own table, we kind of want to see the vertex in the middle. All right, so I'm going to find my vertex. There it is. It's at -2, -9, and I'm going to build my table around that. -2, -9, and then we're just going to fill it in. And then what I want you guys to do also is drop your calculators, and then after you get done with that, I want you to actually, just like we did yesterday, I want you to label those key features because it's good for us to keep doing that. So I'm going to label my zeros, if I can see them, my y-intercept, and my vertex. Every key feature that I can see, every one of those key points, I want to label them because, again, that keeps them together. You don't have to, but it probably wouldn't be a terrible idea to just connect your symmetrical pairs because, again, it keeps it in your mind that we have symmetrical pairs and that there's going to be a partner. It's good for any quadratic. I usually actually do that for every quadratic. I circle the vertex and I connect the symmetrical pairs, just kind of almost by reflex. Then once you're done with that, I want you to carefully plot these points. Now, I'm talking, don't be doing janky graphing. I mean, it needs to be like as precise as you can make it. And then I want you to connect those points up. And I'll talk to you in a minute about something that I need y'all to be careful about. But let's go ahead and plot these points and see where that gets us. And then I'm going to actually add a point. I'm going to add that point at 2, 7 just so I can see the shape of my parabola a little bit better. Y'all don't have to if you don't want to, but I'm going to. I always do one side of the parabola better than the other one. Like, look at that. That looks almost perfect, and then that looks like I sneezed in the middle of it. I'm not happy. It's going to be okay. Now, while you guys are plotting these points, something I want you guys to be careful of is kind of your tendency is to only plot the points that are on in your table. I want y'all to get past that because what ends up happening is if you only plot those points, then some part of your brain thinks those are the only points that are allowed, and then you box it in, and then suddenly you're boxing in your domain and range. So remember, unless there's a situation or like point plot things that are already graphed that are limiting it, your graph goes on forever, so you need to continue your graph and put those arrows at the end of it. And honestly, I would make them go all the way off. Some people like to put their arrows down here. I make it go as far off the graph as I can. Okay, because you want to kind of constantly be reminding yourself we keep moving on forever. Okay? Take a minute, and then I'll give you all about maybe 30 more seconds to get that graphed and plotted and all that other good stuff. Okay? Somebody get the door, please. All right. So what we're going to do now is we're going to look at the value they gave us. Okay? So they told me 0 equals x squared plus 4x plus 5. So when y is 0, I'm trying to figure out what x is. Well, when y is 0, I could see that in my graph here. When y is 0, x is -5 and x is -1. I can also see it if I draw a line, if I draw a line through through y equals 0. Well, y equals 0 is my x-axis. So if I draw a line through that, I can see that I have 2 points where x is 0, or y is 0. I have one at -5 and I have one at +1, just like my table is showing me. Okay? So what that means is when y equals 0, x equals -5, x equals +1. So when y is 0, I have those two values. And I did all of that because this was 0. So if you don't see a 0, so like if they say y equals, we can kind of assume, well, no you can't, but usually a lot of times in Algebra 1 it's set to 0. For most of the mathematical processes we're going to learn later on, we have to set it equal to 0. So we have to subtract 0 from, like, we would have to get, like, say if this was 9, we'd subtract 9 from both sides and change the equation. Okay? But in this case, since it's 0, we're going to look at the row where y is 0, and that's the x-axis. So we're looking for roots, zeros, solutions, x-intercepts. Okay? For this one, we're looking at 9. So let's pretend that this one, it said 9 equals x squared plus, well, let's say 7. Say 7 equals x squared plus 4x plus 5. I wouldn't look at 0, I'd look at 7. And I see, well, where does it cross 7? Well, it crosses 7 at -6 and +2. Do you see what I'm saying? So whatever it's equal to, and this only really applies to graphing. That's the reason why I said, like, most of the time solutions means x-intercepts. When I'm graphing, though, I can look at the line that it crosses on the graph instead of having to set it equal to 0. Does that make sense? Does it?
Yes.
Great. Okay, good. All right, I want you guys to try the same process that we just did over here, but I want you to do it on the second one. Do not work ahead, please. Okay, well, calculator. Okay, so we are filling this in. Okay. Okay. And then again, don't forget, just as a matter of habit, I want you to label your important values. And if you want to, you can connect your symmetrical pairs. And again, remember when you connect those points up, draw an arrow. Okay, y'all, that's a pretty good looking parabola right there. I'm not mad. I'm not mad about that. And since I'm looking for 0, let's circle 0, circle 0. Y is 0, x equals -3. Okay, y'all should only need a few more seconds to work on that one. So how many times do I have a y value of 0? Only one for this one. And the only way that can happen is if the vertex is the point that touches that. Because remember, the vertex is the only one that doesn't have a symmetrical pair. this is the only one without a partner, it's the only one that can be. Did you guys get this? Is this what y'all got on yours?
Yes.
Okay. We good? What questions can I answer so far? None? We're all good? We're not at the club. We're all good? Mikey, you good? Okay. Okay, so for this last one, I want you to change that from plus 36 to plus 4. Okay. Also, please pay attention to this negative. I want you to plot this one, and then we're going to come back for a conversation, because you might find yourself going, what? Or you might not. We'll see what happens.
That means you just go to the y value of 9.
Yes. Yes, it does mean you just go to the y value of 9. Okay.
It's going to be something. I forgot what it's called, but it's going to be something.
Again, I'm going to go ahead and plot 6, negative 8, and negative 2, negative 8, just so I can see the shape of the parabola a little bit better. Huh? Okay. Not my best parabola, not my worst parabola. It's okay. Why do I have a z there?
No, the bottom. Oh, yeah, both.
See, because look, if you see, my y value is going to be 0 somewhere between here. Somewhere between 4 and 5. And then it's also, see, because it's passing between positive and negative, that means 0 happens somewhere in the middle here. And actually, if you look at the graph, you can kind of see the same thing. Maybe. Yeah. So you see how, like, kind of between 0 and 1, it crosses. So somewhere in the middle there, not exactly sure where, but somewhere between negative 0 and negative 1, I have a 0. And somewhere between 4 and 5, I have another 0. Okay? So again, I mean, you don't have to put those, but you should be able to identify those zeros that happen in between. Okay? And now I'm going to put my line at 9. Spoiler. So, what's happening here? Well, yes, actually it is a reflection. Thank you for noticing that. That's not what we're learning, but that's a good observation, a very good observation. It means I've got a maximum. It means my range is going to be less than or equal to. So there's a billion things you can get out of that observation. So good catch there. And that all happened, by the way, because A was negative here. Okay? Now, what's happening, though? It doesn't touch 9, does it? So, let me get the right color pen. So since the parabola turns around before it hits 9, before it hits y equals 9, there is no real solution. so it crosses at 0 points. Okay? And that's why that happens. It happens because the parabola turns around before it hits y equals 9. I mean, you can even see it here. It goes -1, 4, 7, 8, oh, bye, go back down to 7. I mean, it turns right around at 8. So it never hits that point. Okay? The only time you're going to worry about y being a different number, the only time you're going to let y stay that number is when you're looking at a graph. Every other time, we're going to get this set equal to 0. And that's the reason why, unless you're graphing, usually a solution is a value when is a value when y is 0. Okay? So this is on a graph is the only time you're really going to do this, because we can actually physically slide a ruler or a straight edge or a piece of paper up to show us what happens when it crosses that point. Okay, what questions can I answer about this? You think no questions? We're good?
Yeah.